So we're going to work some more today on multiplying polynomials, just like we did last time. Only this time we're going to do some larger polynomials. This, for example, is a binomial multiplied by a trinomial, because there are 3 terms. And we're also going to work on multiplying multivariable polynomials, which is polynomials that have 2 or 3 or 12 different variables in them. So there are 2 ways that you can solve this. We learned them both yesterday. One of the ways that you can solve it is by using the distributive property. So to use the distributive property, the 9g, which is the next thing our cell phones will be on, needs to be multiplied by the 2g squared, the minus 6g, and the plus 1. So we can do 9g times 2g squared, or not 2g squared. Then 9g multiplied by minus 6g. Even if she's not in algebra, she can still appreciate a classic 2g or not 2g joke. And then 9g times 1. That's the great thing about my hilarious jokes. They are universal. Everyone finds them delightful. Then we do the distributive property again with the 4. 4 times 2g squared. And I'm writing these on a second line, not because you need to, but because my first line is out of space. 4 times negative 6g. And 4 times 1. I'm going to put plus signs in between all of these because they're all going to be added together. And then I will pause to give you a moment to catch up with your note taking. And also to sweep these minds. Pew, 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 pew. This is clearly the messiest part of the problem, the part where you multiply everything. From here on out, the problem's just going to get smaller and smaller and smaller until we're down to the end. The next thing that we'll do is multiply all the stuff together that is being multiplied. Then we will combine our like terms, and then victory will be ours. So 9g times 2g squared is what we will do first. You multiply the numbers first, so 9 times 2. And then we multiply the variables. G multiplied by g squared is g cubed. Very good. Then we do 9g times negative 6g. So we multiply the constants first. 9 times negative 6 is? Negative I don't know is really close. It is negative.
I don't know what 9 times 6 is.
Me neither. I heard somebody say it. Negative 54. And then we multiply the g's. G times g is g squared. And finally, 9g times 1 is really easy because anything times 1 is itself. So 9g times 1 is 9g. And those are added. Now let's work on the second row here. 4 times 2g squared. How about 8g squared? Because the 4 doesn't have a g.
Oh, yeah. Sorry.
Okay, 4 times negative 6g. 4 times negative 6 is negative 24. Good. And 1 lonely g. And then finally, 4 times 1. And we're always adding. ABC, always be adding.
Wait, Wait, can we combine values that are negative and one's negative, one's positive? No.
Very good question. She asked, can we combine values when one is negative and one is positive? And the answer is yes, as long as, this is the part where you complete my sentence, as long as they have the same, with the same power or exponent. Good. So,
Negative 54 g squared.
well, let's start off with the biggest exponent and work our way down. So what's the biggest exponent here? Is cubed. Cubed is the biggest exponent. Do we have anything else in this problem that has a cubed exponent? No. So that means poor 18g cubed all by himself. Okay. Now what?
You have 2 squared.
All right. We have negative 54g squared and we have 8g squared. So we would need to combine negative 54 and 8.
Which would be negative 6.
Very good. Negative 46 g squared. Then what?
Yeah. 9g and negative
9g and negative 24g.
negative.
It would be negative. What's 24 minus 9? So negative 15g.
I'm sorry.
And then our poor little 4 right here. No love. Now, before I'm willing to say that is the answer, I want to do one more look over the problem and see, is there anything in that problem that can be combined?
No.
No. So this is our solution. Arthur Morgan says epic. Yes, you are correct, Arthur Morgan. Epic. Okay, so let's do a multivariable. What am I talking about with multivariable? Well, I'm going to give you some polynomials that have 2 different variables. For example, that first one's got a y and a w. What? You know, some people say that algebra is not very exciting, but I don't think they've ever seen a problem that has 2 different variables in it. This is really quite extraordinary. Now, on the last problem, the way that we did it was with the distributive property. You took the first thing and multiplied it by all 3, and then you took the second thing and multiplied it by all 3. But I said there were 2 ways to do it, and the other way we also learned yesterday is by making a table. So let's solve this one by making the table. Yeah, it needs 6 boxes in there because it's a binomial times a trinomial. Yep. Now I'm going to do 2 rows and 3 columns, but you could do 3 rows and 2 columns. It doesn't matter. What does matter is that the binomial goes along the side that has 2. So negative y and negative 3w. And then the trinomial goes across the side that has 3 boxes. Good. So we fill in the boxes like so. 7y times negative y is negative 7y.
Could be wrong, but
What's W times negative Y?
It's negative YW.
Very good. Excellent work. Because those are different variables, I can't like put them together with an exponent or anything. They're just stuck as is.
And then positive 5y.
Very good. Positive because it is a negative times a negative. Negative 5 times negative y. Positive 5y. This is how we do it.
21.
Mm-hmm. Very good. Negative 21. You said WY, which is fine. I'm going to do YW, not because I have to, but because you told me YW for the other one.
Okay.
So I'm just going to keep them all in the same order. Okay, what goes in the next box?
Negative 3w².
Mm-hmm. And then
15w.
mm-hmm. And so now that I have this done, I'm going to just take what was in the squares here, and I'm just going to write them out. So negative 7y squared minus yw plus 5y minus 21yw minus 3w squared plus 15w. That's the stuff that was in the boxes just written out. The order that you write them in is not a big deal.
I was going to ask you that yesterday, and I was like, probably don't know.
General math convention is start with the biggest exponent and work your way down. So I started with the y squared and then y to the first and then y to the 0th, which is what the ones with the w's are.
I'm sure you can combine.
You did? Okay.
Negative YW with negative 21y.
Mm-hmm. Negative YW and negative 21YW. When I combine those, what do I get?
Negative 21. No, positive 21 YW².
You're multiplying them.
Oh,
What you did just now was multiplying.
oh,
I want to add them. It's a negative 1 and a negative 21.
okay, so yeah, now it's negative 22
Yeah, quite up.
YW².
Not YW squared. The variables
Oh, no,
don't
that's correct. Okay.
variables don't change if I'm adding and subtracting. Variables don't change when I combine them.
Well, but I thought that would, yeah, never mind.
If you have 3 oranges and I have 2 oranges and we put them together, we don't have 5 squared oranges. We just have 5
Sorry,
oranges.
I get confused sometimes.
It's all good. The negative 7y squared doesn't look like he has a buddy at all. Poor fella. Does not look like the 5y has a buddy. Doesn't look like the 3w squared has a buddy. And doesn't look like the 15w has a buddy. So that is a really upsetting answer because it's enormous. But that's why we judge things based on the quality of their character and not their physical appearance. I have a dream that one day we will judge a math problem by the knowledge it gives us in our brains, not by the horrific, deplorable appearance of the answer.
I'm putting that in my Instagram.
I have a dream.
You have to do it on MLK Day, though.
That sounds appropriate. I will honor Martin Luther King by using his speech to promote math. I'm sure that won't make anybody mad. Okay. So I'm going to give you 2 formulas here that we're going to use now, and then we will also use them at the end of this school year when we do factoring. So these are going to be, factoring is definitely something the math team needs to review. Factoring is fun. Factoring cubes is not like my favorite thing in the whole world. But we're
Just factoring in general is kind of. I'm talking about fractions, but I do not like fractions. No, it's not fact.
you will not factor today or tomorrow or the next day or the next day or the next day, but you will factor eventually. And factoring squares is kind of fun. Factoring cubes is the opposite of fun or not fun.
You should just say brutal. An unholy nightmare.
I don't.
Never been, created in the first place. The math gods.
It was created in a lab by the Chinese. They sent us some indifference of cubes.
Knowing them, they probably did.
Let's see. Actually, it's probably the French. Now that I think about it. Oh, those filthy French.
Those yellow bellies.
They send us the cubes. Sacre bleu. That's my French accent. Sacre bleu, the cubes, they have invaded. Okay.
You sound like German at the end.
Do you want to do cubes? 9?
Germany? Where are they from Germany and not Cuba?
Oh, yeah. Some indifferences of cubes came from Cuba.
That's sad.
Wow, that is a disappointing and also fabulous joke. They came from Cuba. JFK messed up.
The COVID square.
He messed up. He banned Cuban cigars. Should have banned just cubes in general. Of course, it would have been devastating to the Rubik's industry.
The COVID cube. They come from Russia.
So the formula for sum of cubes and difference of cubes gives you a sort of fast way to go straight from this multiplication of polynomials that I wrote out, the d plus 5 and the d squared minus 5d plus 25, and go straight to the answer, which has the form a cubed plus b cubed. So if I were to take the formula here, this is the a plus b. This is the a squared minus ab plus b squared, if I follow the formula. So in this particular problem, a is what? I'm about to say one of the most nonsensical things you'll ever hear. In this problem, a is d. Everywhere we have an a is a d. A squared was d squared. Here's the a again.
You know, I get when my mom says she doesn't understand math now.
Really? You get it now? Oops, that's not right. Calm down.
Chris.
People keep talking to me.
So a is equal to d. B is equal to
No, numbers. Numbers,
which number specifically?
5.
5. So to get the solution to this, I can take the a cubed plus b cubed.
What if they're not on the same row?
Then you can't use this. This will give me d cubed plus 5 cubed. Now d cubed plus 5 cubed is a perfectly acceptable answer. But the value of 5 cubed is 125, so we could also write it as 125. D cubed plus 5 cubed is fine if you're lazy. So now that you got the hang of that, or now that you've maybe not got the hang of it, but seen it once, one should be enough, right? You don't need to see things more than one time. Let's try this one. This is a difference of cubes. Difference because the first set of parentheses has a minus sign instead of a plus sign. So this is a minus b, a squared plus ab plus b squared. So what's the value of a in this problem? W. And what's the value of b in this problem? 3. So the answer is a cubed minus b cubed. Since in this problem, the a was replaced with w, it'll be w cubed minus 3 cubed, which is a great way to write the answer, but 3 cubed is 27, so we could also write 27 as the answer. Now, what I would like to point out to you is that this is a shortcut. It's not something new. If I take d plus 5, that binomial, and multiply by d squared minus 5d plus 25, I will get d cubed plus 125. This is just a shortcut to go straight to the answer instead of having to do the distributive property or the box. Now, this shortcut only works if it's a sum or difference of cubes, meaning if it follows this specific pattern. Sometimes they do, sometimes they don't. Let me see if I can really bake your noodle. What do you think? Let me rephrase that. What do you think we should do first?
Negative 4x.
What does your dear Aunt Sally say to do first? Parentheses. So let's look at our parentheses. We have x minus 1. Can we combine x minus 1? No, we cannot, because 1 is an x and 1 is not. Those are not like terms. So parentheses are done. What does our Aunt Sally say to do next? Parentheses, then that's distributive property is multiplication. There's something that comes before multiplication and division. Exponents. And we do have one of those. What does x minus 1 squared mean? Probably means x squared minus 1 squared, right, kids? I'm going to hurt you. Squared means multiplied by itself. Are you trying to pick a fight with me? Do you want to see me cry? Is that what you want? Do you want to see me cry? Yeah. Well, bad news for you. I had my tear duct surgically removed.
Yes, I want to see you cry.
Okay.
If you had your tear duct surgically removed, your eyes would also dry.
I'm sorry, I can't hear you. You're too far away. So the next thing that I do is multiplication. It's possible for me to distribute the 2 to the x minus 1 first and then do the distributive property for the parentheses, or I can do the parentheses first. I don't care what you do. I think I'm going to do the parentheses first. Multiply the parentheses together. So I'll have x multiplied by x, which is x squared. Then I'll do x multiplied by -1, which is -x. Then I'll distribute the second thing. I distributed the x to both things in the second set of parentheses. Now I'll distribute the -1. So -1 times x is -1x. -1 times -1 is positive.
Is that it?
I don't know. Is there anything else I can do?
No, wait. We also do distributive with the 2 outside.
Yeah, let's distribute the 2. What a great idea. You are so smart. Your math teacher must be ridiculously handsome. So 2 multiplied by x squared is 2x squared. 2 multiplied by -x is -2x. 2 multiplied by -x again is another -2x. And 2 multiplied by 1 is 2. I had to verify. Yep. And there's a -4x. I got 3 things with x in them that can all be combined. I'm going to start with my biggest exponent, though, and work my way down. So I'm going to start with 2x squared. Yep.
We combine them all at once or 2 and then add them.
It's up to you. -4 minus 2 minus 2 is?
For subtracting it, right?
Mm-hmm.
-6.
-6 is -4 minus 2. And then minus 2 again. Yep.
X.
Yep. And then our constant on the end, +2, does not have any friends. And that is the solution. It's a good thing multiplying polynomials is so much fun because you do it pretty much for the rest of high school. You'll do it in geometry, you'll do it in algebra 2. Or if you're thinking that there's only one escape, and that is to never factor or never multiply polynomials, then you'll do it in algebra 1 next year when you retake it. It never goes away. There's no escape. Polynomials are pretty popular. Any questions from anybody about anything? Nope.
Do you have the ability to help me in communication applications?
Maybe.